You know NVIDIA as the AI giant, the chip powerhouse. But what if I told you that less than 2 decades ago, NVIDIA faced a crisis that almost wiped them out? What pivotal decision saved them? Now commanding $1 trillion valuation, driven by a relentless share surge in revenue that has simply skyrocketed. And how did they pull off the greatest comeback in tech history? Welcome to BitBloom Spectrum, where every bit sparks growth. From the latest tech headlines to daily world news, from fascinating facts and motivational shorts to animated insights, personal breakthroughs, and deep dive company case studies. We decode the world around you, one bit at a time. In this video, we'll see how NVIDIA rose from failure to become the driving force behind today's AI revolution. Now let's bloom into the world of NVIDIA. In 1993, 3 engineers, Jensen Huang, Chris Malachowski, and Curtis Preem, founded NVIDIA in California. At the time, most computers were stuck in 2D. They saw a future of immersive 3D graphics. Instead of using triangle-based rendering, the standard being adopted by the industry, NVIDIA tried something different: quadratic texture mapping. They believed it would produce smoother curves and better 3D graphics. So they built a revolutionary chip, the NV1. In 1995, NVIDIA released its first ever graphics card, the NV1. But game developers were building around DirectX, which used triangles, not curves. That made the NV1 incompatible with most upcoming games. The result? Developers ignored it, gamers avoided it, and NVIDIA lost its first big partnership with Sega. The NV1 flopped, but the lessons learned would eventually shape their greatest breakthrough, the GeForce. 1999, NVIDIA changed everything. They launched the GeForce 256, the world's first GPU. Until then, graphics cards were just accelerators, helping CPUs render 3D scenes. But the GeForce 256 was different. It could handle transform, lighting, triangle setup, and rendering, all on its own. GeForce 256 could process over 10 million polygons per second. Games looked smoother, faster, and more lifelike than ever before. This single chip redefined gaming and laid the foundation for the realistic gaming and AI hardware NVIDIA would build decades later. In 2006, NVIDIA did something no one saw coming. They turned the GPU into something more than a graphics engine. They created CUDA, the Compute Unified Device Architecture. CUDA was a revolutionary platform that allowed developers to use the GPU for general-purpose computing. Not just for rendering games, but for running code, solving math problems, simulating physics, and training neural networks. Before CUDA, most GPUs could only do one thing: make visuals. After CUDA, they became parallel supercomputers, capable of handling thousands of tasks at once. This single innovation unlocked new possibilities in science, medicine, finance, and eventually artificial intelligence. It wasn't just about gaming anymore. It was about global impact. CUDA made NVIDIA the brain behind everything from climate models to ChatGPT. It has a brain. It's called the CPU. It's great at handling a few tasks quickly and in order, like a smart chef making one perfect dish at a time. But a GPU is built differently. Instead of a few powerful cores, it has thousands of smaller ones, designed to handle many tasks at once. Think of it as a huge kitchen staff, each doing a small part of the job simultaneously. CPUs are great for logic, decisions, and system-level operations. GPUs are perfect for rendering images, processing video, and now, thanks to CUDA, solving massive data problems. CUDA is used to program such GPU. Once known only for powering PC games, NVIDIA today is far more than a gaming company. They've become a global force in AI, data centers, robotics, and even self-driving cars. Gaming was where NVIDIA started, and it's still one of its biggest and most iconic businesses. With their A100, H100, and new Blackwell chips, NVIDIA dominates the data center GPU market. These chips help train massive AI models, manage cloud workloads, and accelerate computing across industries. Through the NVIDIA Drive platform, they supply AI systems to Tesla and other automakers for self-driving vehicles, handling perception, navigation, and decision-making. NVIDIA Omniverse is a virtual collaboration platform used for simulating factories, training robots, and even creating digital twins of real-world systems. NVIDIA's gaming segment remains its roots, but it's not just about performance anymore. It's about AI-enhanced, cloud-delivered, next-gen experiences. It's become the infrastructure of intelligence across the modern world. NVIDIA continues to innovate aggressively. The latest Blackwell architecture, along with its chips, targets trillion parameters, AI models pushing the boundaries of speed and efficiency. Their vision of AI factories, data centers designed to create AI intelligence, cements NVIDIA role as central platform powering AI across industries globally. GPU has hundreds or thousands of smaller cores, built to do many tasks at once, perfect for handling large amounts of data in parallel. That's why GPUs are ideal for training AI models, running real-time graphics, and powering simulations. Originally designed for rendering 3D graphics, GPUs are now used for AI, simulations, and more. This massive parallel processing power is exactly what fuels NVIDIA's RTX systems. Ray tracing is a graphics technique that simulates how light actually behaves in the real world. Instead of faking shadows and reflections like older methods, ray tracing traces the path of individual rays of light as they bounce around a scene. The result? Games in 3D environments that look more like movies. Glass reflects like real glass, shadows fall naturally, and lighting reacts to your every move. This cutting-edge ray tracing technology is used in NVIDIA's GeForce RTX series, bringing lifelike lighting, shadows, and reflections to real-time gameplay. A pixel is the smallest unit of a digital image. Think of it like a colored dot. Thousands or millions of these dots are arranged in a grid to create the images you see on screen. Each pixel holds color information: red, green, blue, and when combined, they form complex visuals like characters, landscapes, and effects. Your graphics card calculates what color each pixel should be, dozens of times per second. That's how it creates moving images. Rendering every pixel in high resolution takes a lot of GPU power. That's where DLSS comes in. DLSS starts by rendering the image at a lower resolution. Fewer pixels, faster performance. Then it uses a deep learning neural network trained on super high resolution images to intelligently upscale the image. It doesn't just stretch or blur. DLSS predicts what each missing pixel should look like. The result? An image that looks sharp, detailed, and high resolution, but uses far less GPU power to create. A data center is a physical facility that houses thousands or even millions of computer servers. These servers store, process, and manage huge amounts of digital data. Every time you watch a YouTube video, use Google Maps, or talk to an AI, you're interacting with a data center somewhere in the world. NVIDIA DGX is part of such data center mechanism. It is a powerful AI supercomputing platform built specifically for training massive machine learning models. It's not just one GPU, it's an entire AI system packed with multiple high-end NVIDIA GPUs, high-speed networking, and AI-optimized software. DGX systems are used in modern data centers to train AI models faster, more efficiently, and at huge scale. NVIDIA Drive is an end-to-end AI platform built specifically for autonomous vehicles and smart transportation. It combines powerful automotive-grade GPUs with deep learning software, enabling cars to see, understand, and make decisions on the road. In short, it's the brain of a self-driving car. The Drive platform processes data from a car's sensors, cameras, radar, LiDAR, and ultrasonic systems. It uses real-time AI to recognize traffic signs, detect pedestrians, measure distances, and predict the behavior of other vehicles. Using deep neural networks, Drive can make instant driving decisions, like changing lanes, stopping at lights, or avoiding collisions. And it does this with ultra-low latency and automotive-grade safety. NVIDIA is no longer just a chip maker. It's one of the most valuable companies in the world. In 2025, NVIDIA crossed a $3.5 trillion market cap, becoming the most valuable company by beating Apple and Microsoft. Its data center business, powered by AI demand, now brings in over 70% of total revenue. Quarterly revenues have exceeded $26 billion, with net profits reaching historic highs. And the demand for AI chips like the H100 and Blackwell continues to grow globally. Key financial highlights: market cap approximately $3 trillion, quarterly revenue $26+ billion, data center revenue $20+ billion per quarter, profit margin approximately 70% gross margin, R&D investment approximately $8 billion plus per year. NVIDIA's customer base spans across nearly every major tech sector, from AI startups to global superpowers. Their chips don't just power games, they power AI, cloud computing, healthcare, robotics, and more. NVIDIA designs its own chips, but it doesn't manufacture them. Instead, it uses a model called fabless manufacturing, where the design and architecture are done by NVIDIA, but the physical chips are built by another company, and that company is TSMC. The silicon is then packaged, tested, and assembled by partners like Foxconn, ASE, and Amkor. Before being shipped to data centers, PC manufacturers, or sovereign AI partners around the world. Let's take a look at the latest 2025 NVIDIA conference, where they unveiled their most advanced AI chip in data center technology yet. In 2025, NVIDIA signed a major AI hardware deal with Saudi Arabia, a move that signals the country's rapid push into artificial intelligence infrastructure. Through a government-backed company called Humane, Saudi Arabia agreed to purchase over 18,000 NVIDIA GPUs. This deal is part of the kingdom's massive $600 billion pledge to become a global leader in AI, research, and sovereign compute power. NVIDIA's technology will be used to build massive AI data centers, train national LLMs, and power everything from healthcare to smart cities. It's one of the largest sovereign AI infrastructure partnerships ever, and positions Saudi Arabia as a key customer in NVIDIA's global expansion. Huawei, the emerging contender with AI chips. Huawei is developing its own AI chips under the Ascend series, aiming at cloud, AI, and telecom infrastructure. Huawei faces geopolitical and supply chain challenges, but is aggressively pushing domestic semiconductor innovation to reduce dependence on U.S. tech. They focus on AI accelerators and edge computing and aim to compete in the China market and beyond. Huawei's chips are less known globally compared to NVIDIA and AMD, but are rapidly evolving. AMD, the challenger in GPUs and CPUs. AMD competes directly with NVIDIA in graphics cards, Radeon versus GeForce. Over recent years, AMD has gained ground with competitive GPUs built on RDNA architectures, especially in gaming and workstation markets. For AI, AMD has been expanding its MI series targeting data center AI workloads, trying to chip away at NVIDIA's dominance. AMD leverages open standards like ROCm to appeal to developers who want alternatives to NVIDIA's CUDA. NVIDIA's future is deeply tied to AI, data centers, automotive, and global infrastructure. They're expanding into sovereign AI deals, working with countries like Saudi Arabia and the UAE to build AI data hubs. Their new Blackwell architecture promises 25 times performance improvements for trillion-parameter models. Beyond chips, NVIDIA is growing in software too, with platforms like Omniverse, CUDA, DGX Cloud, and NVIDIA AI Enterprise. This positions them not just as a hardware vendor, but as a full-stack AI powerhouse. If you enjoyed this video, don't forget to like, subscribe, and drop a comment below. Hit the bell icon so you never miss a bit from BitBloom Spectrum. Thank you for watching. See you in the next one.